All right, scholars, we're going to finish up how to find the lateral area and surface area of cones, but I want to show you the next problem because I don't want you to forget this process. This will show up on a quiz or a test, and you have to know how to do it. The main thing is, if I'm looking for lateral area and surface area, I need to know my radius and my slant height. Now, we're going to have to know height later. Now, this is the height, how tall it is for volume, but I don't need to know it yet. So when they give me that and not the slant height, like in this scenario, I have to solve it. Well, what type of triangle do you see there being formed? And if I know two sides, how do I solve for the missing side? That's right, the Pythagorean theorem. Some of you go, oh, 8, 15, 17. You're right. The slant height is 17 because that's a Pythagorean triple. But if you forget, you must go 15 squared plus 8 squared equals slant height squared, and then you're going to have to solve for it and get the fact it's still 17. So no matter what, you should be able to solve this. So I'm going to go ahead and plug in the fact I know my slant height is 17, my radius is 8, so my lateral area is going to end up being 136 pi square inches. My surface area, again, is just my lateral area plus the area of the base. So I'm going to go 136 pi plus pi times the radius squared. So 136 pi plus 64 pi. I add them together because when the pi's come along, I get 200 pi. Oops, I just said centimeters. I need to stay with inches. I don't need to change my units. Not too bad, is it? All right, let's do the next one. When I do this one, notice they gave you the whole thing. The whole thing's a diameter. I don't know how many times I've had people go, oh, I know, I'm going to have to use 16 for my radius. No, your radius is half of it. Your radius is 8. Now, look at this right triangle again. I still don't know my slant height. This is my height. That's my radius. That's a 6, 8, 10. All right, remember, to find your slant height, use the Pythagorean triple, if it has one, or the Pythagorean theorem. It will, you solve for it, excuse me, every time. Now that we have the slant height, we can plug it in for lateral area and surface area. Pi times the radius, which is 8. My slant height is 10. That's 80 pi square centimeters. Surface area is your lateral area plus the area of your base. So 80 pi plus pi. Our radius is 8, so 8 squared. 80 pi plus 64 pi equals 145 pi square centimeters. Hopefully that helped a little bit more on this one. And let's finish it up. Okay, let me remind you some rules. When you have what's called a composite figure, divide and conquer. What makes this composite figure? You have two cones, different sides, that share the same base. But if they're sharing a base, is that exposed to the surface, the air? Because anything that's on surface has to be exposed to the air, and that wouldn't be the case. So I don't need to know the bases of either one of those. So in order, what you have to do, you have to use two lateral areas to find the surface area. And the cool thing is the radius is 6 inches for both. So I'm going to do the lateral area, the one on the right, I'm going to do the lateral area on the one on the left, and then add them together to get the surface area. So the lateral area on the one on the right is pi r times the slant height. So this is the one on the right. I know my radius is 6, because that's what it's pointing to. But notice I don't have a slant height there. Well, do I have a right triangle? 6, 8, that's right, 10 is my slant height. So I put a 10 in here. So I get 60 pi. Then I have, let me move this a little bit more, my lateral area of the one on the left. And that's pi RL. So I get pi. My radius is 6. But the cool thing is they give the slant height this time which is 12, which gives me 72 pi. So the surface area is just the left and the right divided up. Now we're conquering it by putting it back together. 60 pi plus 72 pi, which gives you 132 pi square inches. So it's not too bad when we're looking for the surface area of cones.